In 2015, hurricanes accounted for 0.16% of the U.S. GDP, which is 28 billion in damages. By 2075, hurricane damages are projected to increase to 0.22% of the U.S. GDP, which is 151 billion. A significant percentage of these costs relate to property damage and loss. The intense eyewall winds of Category 5 Hurricane Andrew, for example, destroyed over 25,000 and damaged 101,000 more homes in Florida. Our group chose to structure the Big Good project around this information with the goal to mitigate damage and losses in the event of a hurricane in Miami, Florida. To do this, we first analyzed current mitigation efforts. Temporary relief housing is a reactionary measure that strives to get people into shelters after a hurricane wipes out their residence. We found this mitigation effort to be fraught with issues ranging from political to logistical. Additionally, while these shelters are meant to be temporary, they often last for years and years, which creates a whole new set of issues. Cameron Sinclair, an architect and social entrepreneur, describes it.
Every disaster, everyone's like, well, let's just build 4 walls and a roof and they'll be fine and we can walk away. And what you're doing is you're building future ghettos, which then become areas of crime, neglect, and then when a disaster happens again, everyone is affected. So we have to figure out the mechanism that empowers people to look beyond their current problem.
We also analyzed BIG's Dryline, which is a 10-mile waterfront park in Manhattan. Solutions like the Dryline are beneficial in a multitude of ways since they are able to protect from flooding as well as increase public waterfront space. As Bjarkingel says, if you're going to do something anyway, then you might as well give it a public benefit. We also studied the Netherlands, known for advanced flood mitigation strategies. They use a combination of storm barriers, dams, dikes, and gates along their coastline, and inland storm barriers are dual-purposed in such a way that they manage to actually gain energy from tides and wind to power their cities. Finally, we studied mangroves, which can reduce wave height by 20% due to the drag of water moving through roots. While mangroves do take about 15 years to grow, their benefits far outweigh the wait time. The trees provide valuable ecosystem services to the local community that other types of barriers cannot. Mangrove trees purify water, cycle nutrients, prevent shoreline loss and soil erosion, provide high-quality fisheries habitat, offer recreational and educational opportunities, and sequester carbon. Our group took what we learned from the dryline, Netherlands, and mangrove trees in order to create a coastal barrier. It is made up of hexagonal architectural systems and mangrove trees that will minimize the impact of hurricanes along the Miami coast. The architectural system acts as a protector for the mangroves while they grow and as a recreation area for beachgoers. It also functions as a physical barrier between the streetscape and a potentially devastating flood. Our project is a viable mitigation effort because it is able to protect existing infrastructure, some of which is historic, without taking away from the Miami Beach experience. Vendors, tourists, and locals alike will be able to enjoy the new boardwalk-esque barrier year-round. Additionally, the state of Florida will be happy to see the return of mangrove trees, a native species, which are often illegally cut down elsewhere along the coast for boat shows and other commercial activities. At the end of the day, this project is about more than minimizing hurricane damage. It is about our values: community, enjoyment, and nature.